So here we need to isolate those divisors of that number, and those could take forms something like this. This is just one example of a divisor. We're looking for specific ones that when you divide by 3 gives you a remainder of 1. Clearly that won't work because this is a multiple of 3. So we have to kind of exclude all powers of 3 because that would give you a remainder of 0. So essentially we are trying to create divisors from these remaining powers of these 3 primes. Now the easiest way to start is to first list out these components which give you a remainder of 1 when divided by 3. So this could be 1, 2 to the 2, and then 2 to the 4, and 2 to the 6. You'll see the odd powers don't do the job because 4 divided by 3 gives you a remainder of 1. When you square that 4, which is 2 to the 4, will also give you a remainder. And you can check 16 divided by 3 gives you a remainder of 1. And then 2 to the 6. So all 4 of these would give you a remainder of 1 when divided by 3. We'll do the same thing with 5 cube. It would be 1, and then 5 square, which is 25, also gives you. So those are my 2 choices here. And same thing with 7 square. It could be 1, 7 to the 1, 7 square. So we have 3 choices here. So any combination, meaning 2 to the 4 paired with 5 square to the 7, this would be one example of a number or a factor which will give you a remainder of 1. Why? Because each one of these, when divided by 3, gives you a remainder of 1. And if you're multiplying these 3, you just multiply those remainders, gives you 1. When then divided by 3 gives you a remainder of 1. So I have 4 choices here. And I just need to count how many ways I can connect these. 2 here and 3 here. So if I multiply that, that gets me to 24. Now there are other cases also have to consider where the other powers here, which are 2 cube and 2 to the 1 and 2 to the 5. All 3 of these will give you a remainder of 2. Because anytime you divide a power of 2 by 3, you will only get remainders either 0, 1, or 2. So these 3 give you remainders of 2. Now when we come to 5, powers of 5, the one that we didn't consider so far is 5 cube, which gives you a remainder of 2. And when you multiply those 2 numbers, for example, 2 to the 1 times, actually I have to also consider 5 to the 1. So 2 times 5 to the 1, you'll notice each one when divided by 3 gives you a remainder of 2. So if you multiply the remainders, that gives you 4. And then if you divide that 4 by 3, you get a remainder of 1. And you can also see 2 times 5 is 10. 10 divided by 3 does indeed give you a remainder of 1. So we need to consider those powers of 2's that give you a remainder of 2 when divided by 3. So I have 3 of those choices here. 2 here, 5 to the 1 and 5 cube. And then here, I have to consider all 3. And again, it's about counting, meaning you would be pairing them like this. Like that. And notice I'm not going to include a 1 and a 1 here because I've already counted those here. So I have 3 choices here for the 2's, 2 for that, and then 3 here. If you multiply that, you get 18 more of those. And their examples would be this. This would be a number that divided by 3 gives you a remainder of 1. So earlier we had 24 and then 18 more. That means there's a total of 42 such factors, which is choice D. So it is a hard question. I'm kind of approaching it from not the modulo approach, but just the kind of going back to the basics. But it is a hard question because you have to kind of consider all these different cases where you could get different remainders, their product getting you a remainder of 1 when divided by 3. So it's a hard question. The answer is D.